when we say index notation, it is the simplest way to write indexes. When we have a number like 2 power 4, we say this number is in the index notation or index form. Okay, so the number at the down, that is the 2, is called base. So this is called the base. And the number at the top is called power. Or exponent. Or index. So this number can be pronounced as 2 exponent 4 or 2 power 4 or 2 index 4. Alright, so when we have 2 exponent 4, it means that this base, the 2, is multiplying itself 4 times. Are you getting it? So this in the expanded form can be 2 times 2 times 2 times 2. How many times? 1, 2, 3, 4 times. Do you get it? Alright, so let's take example. Okay, so we have example on the board, 2 examples, and the first example is write the following in the expanded form. Write the following in the expanded form. The second one is write the following in the index form. So I'm trying this, then I'll give you an example. Okay, so the first one is a exponent 6. So from our previous understanding, we know that a exponent 6 means a is multiplying itself 6 times. So let's go. I'm going to get a times a times a 6 times. So 1, 2, 3, 4, 5. The last one is 6 times. Alright, so this is in the expanded form. Number 2 is y exponent 5 or y power 5. It means y is multiplying itself 5 times. So y times y times y times y times y. And the next one is 6 exponent 3. 6 exponent 3 means 6 is multiplying itself 3 times. So 6 times 6 times 6. So this is in the expanded form. Do you get it? Okay, now let's take number 2. It says write the following in the index form. It means that this has already been expanded, so simply write it in the question form or the index form. So when we have 7 multiplying itself, you count the number of you just write the 7 as 1. So here is going to be 7. Okay, it's going to be 7. Okay, I think the camera cannot see that direction. Okay, then you count the number of times the 7 multiplied itself. So 1, 2, 3, 4, 5, 6, 7. So it's going to be 7 exponent 7. And a exponent, okay, so 4. Okay, so the first law of indices says that when 2 index numbers are multiplying and the bases are the same, just add the exponent. So when we have, let's say, a exponent m times a exponent n. See, these are 2 index numbers multiplying, but the bases are the same. So the first law says that just add the powers. So the answer is going to be a m plus n. And when we take example, it's going to be, let's take example like 6 exponent 3 times 6 exponent 2. Now since the bases are the same, it's going to be 6 exponent 3 plus 2, and our final answer will be 6 exponent 1, 5. Okay, before we take the property 2, let's look at certain things. You see here we have a power 5 divided by a power 3. If you want to expand this, let's expand the top. A will multiply itself 5 times. 1, 2, 3, 4. And here too, the a will multiply itself 3 times. Very good. So we can cancel. This will cancel this. This will cancel this. This will cancel this. Now we've gotten a times a, which is equal to a power 2. Do you get it? So our second law says that when Instead of you going through all this long method, our second property will make it very simple for us. And so our second law says that when two index are dividing and the powers and the bases are the same, just subtract the exponent. So if this and this are dividing and the bases are the same, you take the base as 1, then you subtract the powers. So it's equal to a exponent 2. You get it? It's equal to a exponent 2. The same way, the same thing. So since they are dividing, so a 5 minus 3 is equal to a exponent 2. Okay, so our second property, which says when two index numbers are dividing and the bases are the same, you just subtract the powers or the exponent. So number one, when we are solving that, we're going to just subtract, write the base as 1, then we subtract the powers. So our final answer will be for number 1. Okay, and when you punch your calculator, you must get an answer. Okay, so our 6 square is equal to 36. When you punch your calculator, you get 36. Okay, so the second one too is the same thing. You write the base as 1, 4 minus 3, and we subtract the powers. So you are getting 5. 4 minus 3 will give us 1, and 5 is 1 and 1 will give us the same as 5. Now let's come to the third one. That one too is the same division. So you write the a as 1, and we subtract the powers. For 5 minus 3 and a square. Since these are not in numerical form, you can't find an answer, so this is our final answer. Now let's take the last one. We are dividing, so we must first divide the coefficient. The 8 divided by 2, that will give us 4. Let's write the x as 1. 4 here, there's 4 here, minus 4 minus 2, by 2 is minus, so it's going to be minus 2. You get it? Yeah, you must subtract, but here the 2 is minus, so it's going to be 4 minus 2. So again will give you 4, so it's going to be 4 plus 2. And here too, you bring your y as 1, negative 2 minus 4. Good. So our final answer will be 4. 2 plus 4 will give you 6, and y negative 6. Okay, so the third law also says that when you have a number raised to the power another number, let's say 2, or raised to the power 3, the law says just multiply the powers to get your final answer. So when we do this, we just multiply, we take the a as 1, multiply this and this to get a 6. That's your final answer. We just apply our third law, which says we must just multiply the powers. Okay, so we write the 4 as 1, and we multiply the powers. 2 times 5, that means 4 exponent 10. Calculator will give you an answer. Here too, we write the 3 as 1, we multiply 4 times 2, which is equal to 3 exponent 8. And here too, we write the y as 1, 3 times 3, which is equal to y exponent 9. Here too, since the numbers are 2, the powers will multiply all the 2 index numbers. Okay, so let's go here. 3 times the power outside 2, then n 4 times the power outside 2. Do you get it? So here our final answer will be let me write it here. 3 times 2 will give you 6, and 4 times 2 will give you 8. Okay, now let's come here to you write your 2 as 1, then you multiply x. Negative 2 times 3 give you negative 6. You write y. Negative 2 times 2 will give you negative 4. That's our third law. So the first property says any number raised to the power 0 is equal to 1. So any number raised to the power 0 is equal to 1. Therefore, a raised to the power 0 is 1, b raised to the power 0 is 1, 100 raised to the power 0 is 1, 1000, 1111 raised to the power 0 is 1, 4000 raised to the power 0 is equal to 1. Any number raised to the power 0 is equal to 1. Okay, the next property also says that the exponent or power of product of two or more numbers affect the two numbers. So, for example, when you have a product of two numbers, let's say a times b, ab, it means that they are multiplying and there's an exponent here. The law says that the exponent affect the two numbers. So it's going to be a power 4, b power 4. Do you get it? Another one too, let's say we have x exponent 2, y exponent 3, or exponent 3. The 3 must affect all the two numbers. So it's going to be x 2 times 3 give you 6, and y 3 times 3 give you 9. That is the second property. The next property, also property 3, is called negative index, and it says that any number raised to the power negative index is equal to the reciprocal of the number raised to the power same but positive index. Here, what this means is that when you have any number raised to the power negative exponent, let's say 2, is the same as the reciprocal or fraction of the same number but exponent. So this is going to be equal to same exponent. Do you get it? When you have a number raised to the power negative exponent, then you write the number as fraction, but the numerator will be equal to 1, then you bring the same number but positive exponent. So when you have 5 exponent negative 3 is the same as 1 over 5 exponent positive 3. Let's take examples on that. Okay, so by applying property 3, this is the same as 1 over 2. Yes, 1 over 2. Okay, because we don't write 1 over 2 exponents 1. It doesn't make sense. So this will give 1 over 2. Here too, you get 1 over 3 exponent 4. Here too, you get 1 over, and write it here, 1 over 5 exponent 2. Here too, you get 1 over a exponent 3. Here too, you get 1 over b. Because exponent 1 we don't write. Do you get it? Good. And listen to this very important thing. What if the question, or you've gotten an answer in a fraction and you want to write it in a whole number? Okay, so in case you have 1 over a exponent 4, if you want to write this as a whole number, you get a exponent negative 4. Don't forget that. Let's take another one. Let's say we have 1 over b as your final answer. It's going to be equal to b negative 1. Finally, when you have 1 over c exponent 4, that will be equal to c negative 4. Very good.